Welcome, dear traveler. Tonight, you are about to embark on a journey unlike any other journey that will take you deep into the silent, invisible, and hauntingly mysterious corners of the cosmos. Before we begin, make yourself comfortable. Find a place where your body can relax completely, where your mind can drift and wander. Let your shoulders soften, your hands rest, and your breathing slow. This is your time to simply exist, to float gently in a sea of thought, where the universe itself becomes your guide, as you close your eyes or settle into a relaxed state. Imagine the sky above you. At first glance, it may seem calm, serene. You might see familiar stars, the comforting glow of your moon, perhaps a distant planet twinkling like a tiny lantern in the dark. But beyond what your eyes can perceive, there lies something far more enigmatic. A realm of shadows, of invisible forces, of secrets that have puzzled humanity for centuries. This is the dark side of the universe. When we gaze at the night sky, we often think we understand it. We see the stars, the galaxies, and the occasional comet streaking across the heavens. We assume that we know the cosmos, that it is a vast yet comprehensible place. But the truth is far stranger. For everything you can see, every shining star, every glowing nebula, every spiral galaxy represents only a tiny fraction of reality. Almost everything else remains hidden, invisible, unknown. Scientists estimate that only about 5% of the universe is made up of the matter that we can detect, touch, or observe directly. The rest, over 95%, is a combination of dark matter and dark energy. Forces that shape galaxies, push them apart, and dominate the fate of the cosmos. We cannot see them, and we cannot yet fully comprehend them. Yet their influence is everywhere. They are the silent architects of the universe, moving unseen, guiding the motion of galaxies, and dictating the ultimate destiny of all that exists. Tonight, we will explore these hidden forces, not with urgency or fear, but with calm curiosity. Imagine drifting through the universe, slowly, as if weightless, free from the pull of gravity and the demands of daily life. You are gliding past stars and planets, past clusters of galaxies that shimmer faintly in the distance. You notice the vast spaces between them, the cosmic voids. These emptinesses stretch farther than you could ever imagine, seemingly infinite, silent, and cold. In this journey, you will meet black holes, the devouring giants of space. You will feel the strange pull of their gravity and sense the unfathomable mysteries within their event horizons. You will encounter the invisible threads of dark matter, holding galaxies together like an unseen web, connecting realms that appear separate, yet are bound by a hidden structure. And you will learn about dark energy, the mysterious force that accelerates the expansion of the universe, slowly stretching the very fabric of reality. Do not fear. This is not a tale of doom. Instead, it is a story of awe, of wonder, and of the quiet majesty of a universe that refuses to reveal all its secrets at once. There is comfort in knowing that some mysteries remain, that some truths are just beyond our reach, inviting us to look deeper, to dream bigger, to let our imagination soar as you listen. Let your mind drift along with the words, like a gentle current guiding you through space. Picture yourself floating past a distant galaxy, a spiral of starlight slowly turning, stars circling its center like dancers in a cosmic waltz. Feel the calm and the stillness of the void, the silence so deep it almost hums. Each moment, each breath, takes you further from the familiar and closer to the unknown. The dark side of the universe is not merely a scientific concept, it is a reflection of our own curiosity and fear, a mirror of the human desire to understand what lies beyond our sight. It asks questions that have no easy answers. What is the universe truly made of? What forces govern its fate? Are we alone in this vast, silent expanse, or is there life and intelligence hidden beyond the stars, hidden in the darkness where our eyes cannot reach? Tonight, let yourself be both observer and dreamer. Let your mind expand with the vastness of space, and let the mysteries of the cosmos gently awaken a sense of wonder within you. With each passing moment, you are entering a realm where the known fades away, and only curiosity remains. So, take a slow breath and let it out. Another, feel yourself sinking deeper into relaxation, as if gravity itself has less hold on you. Visualize the cosmos stretching infinitely in all directions, stars and galaxies floating in a sea of darkness. Remember that the universe is mostly invisible, and yet it surrounds you, enfolds you, and carries you along its silent currents. In this journey, you will not need to rush. Time itself seems to slow in the vastness of space. You may find yourself drifting past phenomena so immense, so strange, that your mind struggles to comprehend them. And that is the beauty of it. The universe does not yield its secrets easily. It invites patience, contemplation, and quiet awe as we move forward. Know that you are safe, that you are simply a witness to the cosmos, a quiet traveler in an infinite landscape. The darkness of space is not emptiness, it is the canvas upon which everything exists. It is the cradle of galaxies, the birthplace of stars, and the stage upon which the story of existence unfolds. Tonight, let us begin our exploration of the dark side of the universe. Let us drift together, calmly, into the unseen, the mysterious, the silent and powerful forces that shape all that is. And let us do so with wonder, curiosity, and the gentle knowledge that some mysteries are meant to inspire, not fear. Close your eyes fully if you wish. Let your mind's eye open instead. Watch as galaxies spin, as invisible threads of dark matter connect distant clusters. As dark energy stretches the cosmos ever outward, feel the subtle hum of creation and the infinite potential of the universe all around you. This is the dark side of the universe, and you are about to discover its hidden, silent majesty. As you continue to drift gently into the calm, imagine yourself leaving the familiar warmth of your world behind. Step by step, you move further into the vastness of space, where silence reigns and light travels only where it can. What you know of the universe, what textbooks, telescopes, and photographs shows only a surface layer, a thin veneer, over a much stranger reality. Tonight, we will begin by exploring that surface. Not to stay there, but to understand how limited our vision truly is. Look out into the night sky in your mind. The stars sparkle, distant suns shining over unimaginable distances. You recognize the constellations, maybe even a familiar planet or two. You see galaxies far away, spiral or elliptical shapes glowing faintly. And yet, all of this, every pinprick of light, every luminous swirls, merely a fraction of what exists. The universe is far larger, far stranger, and far more mysterious than our senses allow us to perceive. For centuries, humans believed the stars were fixed points on a celestial sphere, unchanging and eternal. They were objects to admire, to mythologize, and to use for navigation. As telescopes improved, we realized the universe was much more dynamic. Stars are born and die, galaxies collide, and clusters of galaxies drift across unimaginable expanses. The heavens are alive with motion, yet even this motion is only what we can see. Modern cosmology tells us that everything we observe, the light, the planets, the galaxies, and even the gas between them, makes up only about 5% of the universe. 5%. That means that 95% of the cosmos is invisible, undetectable with our eyes, and largely unexplored by humanity. This invisible majority shapes the universe, dictates its structure, and defines its ultimate fate. Yet for now, it remains a mystery as you continue to float through this cosmic ocean. Imagine the dark matter that threads galaxies together. Picture it as a ghostly web, invisible but holding everything in place. It does not shine, it does not absorb light. and it does not interact with the matter you are familiar with in ways you can easily detect. And yet, without it, galaxies would fly apart. Stars would drift into chaos, and the universe as we know it would not exist. Now, consider dark energy, an even more elusive force. This energy does not pull galaxies together. It pushes them apart. It accelerates the expansion of the universe, stretching the very fabric of space itself. The universe is not merely growing, it is expanding faster and faster, driven by a mysterious, invisible pressure that we barely understand. The cosmic horizon is moving, and some galaxies are already disappearing from view, carried away into the unknown by this relentless force. Even as we contemplate these forces, we must remind ourselves of another truth. The universe is not static. Time is not fixed, and distance is not always what it seems. The speed of light limits what we can see, and so, even when we observe a distant galaxy, we are seeing it as it was millions or even billions of years ago. The universe you see is already ancient history. The present moment, everywhere else, may look completely different. Think now about the cosmic horizon, the boundary beyond which we cannot observe. It is not a wall, not a physical edge, but a limit imposed by light and time. Beyond it lies the unknown, an infinite stretch that may contain galaxies, stars, or perhaps phenomena we cannot even imagine. What exists there? What forces, what structures, what enigmas await in that darkness? It is impossible to know, and that very impossibility is part of the allure, part of the haunting beauty of the universe. The unknown universe challenges our perception of reality itself. What seems solid, permanent, or comprehensible is often only an illusion. The night sky, which we consider familiar and stable, is dynamic, ephemeral, and far more complex than our minds can easily grasp. And while science seeks to explain, to measure, and to predict, there remains a realm where knowledge fades into mystery, where imagination must fill the gaps, and where awe becomes the natural response. Tonight, let yourself float among these uncertainties. Imagine drifting past galaxies that have existed for billions of years, through voids so vast that light itself takes millions of years to cross them. Feel the paradox of invisibility, things that govern the universe yet remain unseen. Sense the quiet hum of cosmic processes, the slow dance of matter and energy that unfolds silently around you, indifferent to time or human understanding. As you drift, you may wonder about your place in all of this. Humanity has often looked to the stars for answers. Yet the stars, the galaxies, and the invisible forces that bind them offer more questions than answers. And perhaps that is precisely why the universe is so captivating. It is a reminder that there is always more to learn, more to discover, and more to marvel at. Let your mind linger on this thought. The universe is mostly unknown. What you see, what you can observe, is only a fraction of reality. The rest is dark, silent, and waiting for us to notice it, to study it, to wonder at it. And tonight, as you listen, you are taking the first steps into that hidden majority, the vast, mysterious realm that lies beyond ordinary perception. This is the first layer of the unknown universe, the surface of a reality far deeper than light can reveal. As we move forward, we will dive further, exploring invisible forces, strange phenomena, and the eerie beauty of the cosmos that exists beyond sight. Relax, breathe, and let yourself drift, weightless, into the unknown. As you continue to drift in the quiet vastness of space, let your mind reach outward. Beyond the stars you can see, beyond the galaxies that shimmer faintly in the distance, there exists a boundary knot, a wall, not a fence, but a limit imposed by the very nature of light and time. This is known as the cosmic horizon, the invisible edge of our observable universe. Everything beyond it is a mystery, a vast expanse that remains forever beyond the reach of our eyes, our telescopes, and even our most powerful instruments. Imagine standing at the edge of a cliff. But this cliff stretches infinitely, fading into darkness that cannot be measured. The universe, vast and silent, extends far beyond what you can perceive. Light from distant galaxies, traveling billions of years, reaches us as faint glimmers, whispers of an era long past. And yet, even that light cannot come from beyond the cosmic horizon. Their reality is hidden in shadow. A reminder of how limited our perception truly is. Think of it as looking across an endless ocean on a foggy night. You can see the waves near you, maybe a distant ship. But the horizon stretches into obscurity, where the water blends with the sky and the eye cannot follow. Beyond that point, there may be islands, mountains, or even storms we cannot know. Similarly, beyond the cosmic horizon, there may be galaxies, black holes, or phenomena that defy imagination. They exist, yet they remain inaccessible, cloaked in the silent darkness of the universe. This boundary is not static. The universe is expanding, and as it does, distant galaxies move farther away from us. Some are already moving faster than light relative to our position, a phenomenon allowed by the stretching of space itself. These galaxies are disappearing from view, receding into the unobservable depths of the cosmos. What once could have been seen is now lost to eternity. Imagine billions of galaxies fading silently, carrying their light, their history, and their secrets away into the void as you drift through this infinite darkness. Consider the idea of invisible structures that exist beyond sight. Even where no stars or galaxies shine, matter and energy may be present. Cosmic filaments, invisible webs of dark matter, stretch across unimaginable distances, connecting the universe in ways that are nearly impossible to comprehend. These structures form the backbone of reality, a hidden skeleton that holds everything in place, guiding the motion of galaxies and shaping the universe on the largest scales. The unknown universe is not merely a physical space. It is a realm that challenges the very limits of human understanding. Every discovery seems to raise new questions, revealing layers of complexity and depth we could never anticipate. For example, when astronomers measure the motion of galaxies, they find that there is far more mass than we can see. This unseen mass dark matter holds galaxies together, defying gravity in ways that our senses cannot perceive. And yet, it exists, silently shaping the universe while remaining invisible. Imagine floating past this cosmic web, threads of unseen matter connecting clusters of galaxies like invisible strings. Light passes through, bending slightly, hinting at the presence of something we cannot directly detect. This is the universe beyond the horizon, a combination of known and unknown, light and shadow, the visible and the invisible. It is a place that humbles the mind, reminding us that even the vastness we can see is only a fraction of what truly exists. And yet, the universe is more than just darkness and empty space. Even in the void, there are hints of motion, energy, and structure. Gravity, time, and energy flow silently, dictating the evolution of galaxies, stars, and planets. The universe beyond the horizon is not empty, it is alive in ways we are only beginning to understand. It may be populated with phenomena beyond imagination, enormous black holes, rogue planets wandering the darkness, or even regions where the laws of physics behave differently than they do here. As you float along this edge, notice the paradoxical nature of the cosmic horizon. It represents both limitation and possibility. It defines the boundary of what is observable, yet it hints at an infinite expanse beyond. It is a silent invitation to wonder, a prompt for the mind to imagine worlds and forces beyond comprehension. In this sense, the unknown universe is not frightening, it is profoundly uninspiring. A space where curiosity and imagination can roam freely. Consider now the passage of time within this vastness. Light from the farthest galaxies is ancient, a message from billions of years ago. Observing these distant points is like looking into the past, witnessing events that unfolded long before the Earth even formed. The universe carries its history in the glow of distant stars, in the silent drift of galaxies, in the expansion of space itself. And yet, beyond the horizon, there may be realities completely disconnected from this timeline, moving and evolving in ways we cannot yet imagine. In this quiet, weightless journey, you are both observer and participant. You move through the universe as it was and as it will be, touching upon mysteries that have existed since the dawn of time. The cosmic horizon reminds us of the limits of perception, the boundary between the known and the unknowable. But it also inspires a profound sense of wonder, a gentle reminder that the universe is vaster, stranger, and more beautiful than we can fully comprehend. So, drift slowly, breathe deeply, and let yourself embrace the mystery. The unknown universe stretches out before you, vast and silent, alive with invisible forces and unseen structures. It is a place of endless fascination, where every glimmer of light and shadow hints at secrets waiting to be discovered. Tonight, you are a quiet traveler, floating along the edge of knowledge, on the verge of exploring the profound and haunting depths of the cosmos that remain forever beyond our reach. As you continue to drift deeper into the cosmic silence, take a moment to consider the nature of the unknown itself. Humans have always been drawn to what they cannot see, yet they have also feared it. The vast, dark expanses of space, invisible forces, and distant horizons beyond perception awaken something ancient within USA's mixture of awe, curiosity, and a subtle, almost instinctual fear. Tonight, we will explore this delicate balance, allowing ourselves to feel the quiet intensity of the unknown universe. Imagine floating in a region of space where no stars shine, where only the faintest traces of distant galaxies hint at their presence. Here, there is nothing familiar, nothing to anchor your senses. The silence is absolute, yet it is not empty. It is filled with possibilities, with forces and phenomena that defy comprehension. In such a place, the mind begins to wander, to imagine what might exist beyond the visible. And that imagination is both beautiful and unsettling. Fear of the unknown is deeply embedded in the human psyche. It is a survival mechanism designed to keep us cautious in the face of unseen threats. And yet, it is also a source of wonder. The same part of the brain that recognizes danger also marvels at mystery. When you stare into the infinite darkness of space, you are encountering a paradox. The unknown is simultaneously frightening and fascinating. The silence itself hums with potential, with secrets that could reveal the true nature of reality or shatter our understanding entirely. Consider black holes. For instance, invisible yet infinitely dense, they warp space and time around them. A single misstep near their event horizon could mean being pulled into an unknowable singularity, where the laws of physics as we know them collapse. These cosmic monsters are not mere science fiction, they exist, quietly, in the depths of the universe. Yet, despite their danger, they captivate us, inviting contemplation and imagination. They are a perfect example of how the unknown can both terrify and mesmerize. Now, think about the invisible forces that govern the cosmos. Dark matter binds galaxies together, its presence inferred only through the motion of stars and the bending of light. Dark energy pushes the universe apart, accelerating its expansion in ways we barely understand. These forces are unseen, yet they dominate reality. The universe is not a predictable, safe place. It's ruled by phenomena beyond our comprehension. And in that realization lies a profound mixture of fear and fascination. As you float, notice how the mind reacts to this awareness. A gentle tension may arise, a feeling that the ground beneath your understanding has shifted. But allow that tension to dissolve into curiosity. Let it guide you rather than control you. The universe's unknown is not meant to threaten, it is meant to inspire, to expand the boundaries of thought, to awaken a deeper sense of connection to the cosmos. Each invisible galaxy, each dark force, each unreachable horizon becomes an invitation to explore not with your body, but with your imagination and wonder. The human mind seeks patterns and meaning. Yet in the vastness of space, certainty is elusive. For every answer we uncover, new questions emerge. What lies beyond the cosmic horizon? Are there other universes, other dimensions, other forms of existence beyond our perception? Could consciousness itself extend into regions of reality that we cannot yet observe? The unknown universe challenges us to accept ambiguity, to embrace uncertainty, and to find comfort in the gentle hum of possibility. Even as fear of the unknown arises, it is paired with a profound calm. Floating among the stars, surrounded by invisible forces, you realize how small yet significant you are. The universe does not rush. It unfolds over billions of years. Each motion, each event occurs in silence, in balance, in a rhythm that is both terrifying and beautiful. The unknown is not chaos, it is order we do not yet understand. A harmony beyond perception. Take a deep breath and let your mind absorb this paradox. The unknown universe is a place of endless questions, of invisible connections, of silent forces that shape everything. It is also a place of serene beauty, where fear and wonder coexist in perfect balance. As you drift through this infinite expanse, you begin to see the dark side of the universe not as a threat, but as a companion, silent, vast, and profoundly alive. Tonight, in this journey, you have glimpsed the surface of the unknown universe. You have floated past the limits of human perception, encountered the silent power of invisible forces, and felt the quiet awe that comes from facing the unknowable. And though there is more to come, darker mysteries, stranger forces, and horizons that stretch beyond imagination, allow yourself to rest in this moment, weightless and calm. Embraced by the silence of the cosmos, the unknown universe is waiting, vast and patient. And you, gentle traveler, are beginning to understand its quiet majesty. As you drift further into the vastness of space, allow your mind to adjust to an even subtler, more mysterious presence. Dark matter. Unlike the stars that shine or the planets that glow faintly, dark matter cannot be seen. It emits no light, absorbs none, and interacts with ordinary matter only through gravity. Yet, it is everywhere, an invisible force silently shaping the universe around you. Tonight, we will explore its discovery, its mysteries, and the profound influence it holds over all that exists. Picture the night sky as astronomers first saw it centuries ago. A map of twinkling stars, wandering planets, and distant nebulae. The cosmos seemed orderly, predictable, and comprehensible. Yet even then, subtle anomalies hinted at something more. As scientists began to measure the rotation of galaxies, a strange pattern emerged. Stars at the edges of galaxies moved far faster than expected, as if an invisible hand were holding the galaxies together. The visible mass, the stars, gas, and dust was not nearly enough to account for this motion. In the 1970s, astronomer Vera Rubin meticulously studied the rotation curves of spiral galaxies. She observed that unlike what Newtonian physics predicted, stars at the outskirts of galaxies were not slowing down. Instead, they moved at a speed almost equal to stars near the center. This was impossible if only visible matter existed. Something unseen was exerting its gravitational influence, binding these galaxies together in a way that defied observation. This invisible mass was later termed dark matter. Imagine floating near a galaxy now. The stars spiral gracefully around its center, tracing paths dictated not only by visible matter, but by an unseen scaffolding that stretches far beyond the luminous regions. This scaffolding is dark matter, forming a hidden web that guides the dance of galaxies across the cosmos. Without it, galaxies would tear themselves apart, and the universe would look very different from the one we inhabit. Dark matter is not a single, easily understood entity. Scientists have proposed various candidates. WIMPs, or weakly interacting massive particles, might exist, drifting silently through space, barely interacting with ordinary matter. Exions could be tiny, nearly massless particles permeating every corner of the cosmos. MACHO's massive compact halo object, such as black holes or faint stars, might contribute partially. Yet none of these have been definitively detected, and the nature of dark matter remains one of the greatest unsolved mysteries in modern physics. Despite its invisibility, dark matter is far from passive. It forms cosmic filaments, enormous threads of gravitational influence that stretch across millions of light years, connecting galaxies and clusters. You are floating now among these filaments, though you cannot see them directly. Imagine their presence as delicate strands holding galaxies in place, like an invisible spiderweb spanning the universe. These filaments are the hidden skeleton of the cosmos, invisible yet essential, guiding the motion of stars and galaxies alike. Consider the profound implications. Dark matter constitutes roughly 27% of the universe, far more than the ordinary matter that we can observe. Its presence affects the evolution of galaxies, the formation of galaxy clusters, and the very structure of the universe on the largest scales. Without dark matter, stars, planets, and life itself may never have formed. It is both the architect and the enigma, silently shaping existence while remaining hidden from all but the most careful observations. And yet, the more we study, the less we seem to understand. Dark matter does not emit, absorb, or reflect light. It does not interact electromagnetically. Its existence is inferred only from the gravitational effects it imposes. Imagine an invisible wind, felt but never seen, shaping the sails of cosmic ships as they traverse the universe. This is the essence of dark matter, a presence that defines reality while remaining forever elusive. As you float silently through this invisible web, consider the wonder and the mystery it inspires. Human beings are natural explorers, eager to uncover secrets and make the invisible visible. Yet dark matter challenges that impulse, resisting every attempt at direct observation. It invites patience, curiosity, and humility. It is a reminder that much of the universe is beyond our senses, and that reality extends far deeper than what our eyes and instruments can detect. Tonight, as you drift through the darkness, let yourself sense this invisible force. Imagine galaxies held together by unseen hands, cosmic filaments stretching across unimaginable distances, and dark matter silently governing the motion of everything around you. It is a silent, powerful presence, mysterious, essential, and profoundly beautiful. This is the discovery of an invisible force. The universe is not only what we sit, is shaped, guided, and dominated by that which remains unseen. And in the silence of space, floating weightless, you can feel its subtle presence, a gentle but undeniable influence on the cosmic dance that surrounds you. As you continue to drift silently through the cosmos, let us turn our attention to the question that has puzzled scientists for decades. What exactly is dark matter? Unlike stars, planets, or gas clouds, dark matter does not emit light. It does not reflect light, and it does not absorb light. It is entirely invisible to our telescopes, yet its gravitational influence shapes the universe in profound ways. Understanding it is like trying to feel the wind. You cannot see it directly, but its effects are undeniable. One of the leading candidates for dark matter is WIMPs, or weakly interacting massive particles. These hypothetical particles are thought to have mass, but interact only through gravity and possibly the weak nuclear force. WIMPs would drift silently through galaxies, passing through ordinary matter without a trace. Billions of them might pass through your body every second, yet you would not notice. They are ghosts in the cosmic web, elusive yet essential for holding galaxies together. Another possibility is ixions, incredibly light and nearly massless particles. Ixions could form a vast invisible field permeating all space, subtly affecting the motion of stars and the behavior of galaxies. Unlike WIMPs, ixions would be almost impossible to detect directly, interacting so weakly with ordinary matter that they remain hidden even in our most sensitive experiments. If ixions exist, they are everywhere, silently guiding the structure of the universe from behind the curtain of invisibility. There are also MACHO's massive compact halo objects. These could include faint stars, rogue planets, or even black holes that are difficult or impossible to detect. MACHOs alone, however, cannot account for all the gravitational effects attributed to dark matter. Instead, they may contribute partially, while the majority of dark matter remains something entirely different. Still unknown, still invisible. Dark matter is more than just particles. It forms vast structures, invisible yet immense. Imagine the universe as a colossal spiderweb with galaxies clinging to invisible threads. These threads are dark matter filaments stretching across millions of light years, connecting galaxy clusters and shaping the large-scale structure of the cosmos. Without this invisible framework, galaxies would drift apart, and the universe would look entirely different from what we observe. Consider the Milky Way, our own galaxy. Its spiral arms, its central bulge, and its halo of stars are all influenced by dark matter. Without it, the stars at the edge would not orbit as they do. They would escape into space, leaving the galaxy unbound. Dark matter, invisible yet omnipresent, acts as the cosmic glue holding galaxies together, silently orchestrating the dance of billions of stars, even on the largest scales. Dark matter determines the architecture of the universe. Cosmic surveys revealed that galaxies are not randomly distributed. They form clusters, superclusters, and vast filaments, leaving enormous voids in between. These patterns arise because dark matter forms the underlying scaffolding, attracting ordinary matter through gravity, and shaping the universe from its invisible foundation. Yet, despite its importance, we have never directly observed dark matter. Experiments deep underground, in space, and at particle colliders have searched for traces of WIMPs, ixions, and other candidates. But so far, the evidence remains indirect. Its existence is inferred entirely from gravitational effects, the motion of galaxies, the bending of light in gravitational lensing, and the cosmic microwave background, the afterglow of the Big Bang. This indirect evidence is compelling, yet mysterious. It tells us that something is there, shaping reality, but refuses to reveal its form. It is like hearing the footsteps of a giant in the dark hue. No, it is present, powerful, and influential, but you cannot see it, cannot touch it, cannot understand it fully. And that mystery is part of the allure, part of the haunting beauty of dark matter as you float through this silent web. Imagine dark matter enveloping every galaxy, every star cluster, every cosmic filament. It is the invisible architect of reality, the hidden force that defines structure, motion, and form. You cannot see it, yet it is more fundamental to existence than nearly anything else in the universe. In this quiet, weightless journey, let yourself feel the paradox of dark matter. It is essential, powerful, and omnipresent, yet invisible, elusive, and profoundly mysterious. It reminds us that reality is far richer than our senses can perceive, that most of the universe is hidden, waiting for patient observation and curiosity to uncover its secrets. Tonight, you are drifting through this hidden framework, sensing its presence in the motion of galaxies and the structure of space itself. Dark matter is not just a scientific concept, it is a cosmic companion, invisible yet intimately connected to all that exists. Its silence is profound, its influence undeniable, and its mystery is a call to wonder, inviting your mind to explore beyond the visible, beyond the known, into the hidden heart of the universe. As you continue your quiet drift through the cosmos, imagine peering into the invisible. How do scientists detect something that cannot be seen, touched, or measured directly? This is the central challenge of understanding dark matter. Despite being invisible, dark matter leaves traces of its presence everywhere, like a shadow that bends the world around it. Tonight, we explore the ingenious ways humanity has developed to sense this elusive substance. The first method of detection relies on gravity. Dark matter cannot be observed with light, but its gravitational pull affects the motion of galaxies and clusters. Astronomers observe the rotation of galaxies and the motion of galaxy clusters to infer the presence of this hidden mass. Without dark matter, stars at the edges of galaxies would escape into space. Instead, they move in a precise, dull, almost puzzling pattern dictated by the invisible substance that permeates the cosmos. Another powerful tool is gravitational lensing, a phenomenon where the light from distant galaxies is bent by the mass of dark matter lying between them and the observer. Imagine peering through a warped lens that twists light in strange ways. This bending reveals the invisible mass that cannot be seen otherwise. Through gravitational lensing, astronomers map the distribution of dark matter across galaxy clusters, tracing the intricate cosmic web that underlies the visible universe. Deep underground, in labs shielded from cosmic rays and radiation, scientists search for direct interactions with dark matter. Detectors like xenon, Lux-Zeppelin, and others are designed to capture the rare instances when a dark matter particle, such as a WIMP, collides with ordinary matter. These collisions are extremely subtle, producing tiny flashes of light or minute vibrations. While such events are incredibly rare, each detection attempt brings us closer to confirming the existence and nature of dark matter. Particle colliders, such as the Large Hadron Collider, offer another window into the unseen. By smashing particles together at near-light speeds, scientists hope to produce dark matter in a controlled environment. Although dark matter itself may not be directly detected, its presence could be inferred from missing energy or unusual particle behavior following high-energy collisions. These experiments extend our understanding of the universe on the smallest scales, probing the fundamental building blocks of reality. Astronomers also study the cosmic microwave background, CMB, the afterglow of the Big Bang, to learn about dark matter. Tiny fluctuations in the CMB reveal how matter clumped together in the early universe. These patterns suggest that invisible mass dark matter was present from the very beginning, guiding the formation of galaxies and the large-scale structure of the cosmos. By analyzing these ancient signals, scientists glimpse the role dark matter played billions of years ago, even in space. Satellites like Gaia track the motion of stars with extreme precision. By observing how stars move within the Milky Way, scientists can infer the distribution of dark matter in our own galaxy. Patterns emerge, revealing the shape and extent of the dark matter halo that surrounds the luminous disk of stars. These observations provide a cosmic map of what cannot be seen, a blueprint of the invisible architecture of our galaxy. Despite these sophisticated methods, dark matter remains frustratingly elusive. Each approach provides pieces of the puzzle, yet the complete picture is still out of reach. It is like hearing echoes in a vast, dark chamber. We sense the presence of something enormous, powerful, and complex, but its full form is hidden. The search for dark matter requires patience, creativity, and an acceptance of uncertainty, willingness to explore the invisible, and confront the unknown. Imagine floating among these experiments and observations, connecting the visible universe with the hidden mass that shapes it. Every galaxy you pass, every cluster you observe, Every subtle motion of stars is evidence of this silent force. It is everywhere, yet nowhere, influencing everything, yet remaining undetected. Its mystery fuels our curiosity, reminding us that the universe is far more complex than our senses alone can reveal. Dark matter detection is not just a scientific quest, it is a philosophical journey. It challenges our assumptions about reality, forcing us to acknowledge that the universe is mostly hidden from view. The structures, forces, and processes that govern existence extend far beyond what we can directly perceive. In this sense, the search for dark matter is a meditation on humility and wonder, a reminder that even in the age of telescopes, satellites, and particle accelerators, much of the cosmos remains a profound mystery. As you drift silently through this invisible web, feel the quiet power of dark matter all around you. Though unseen, it shapes galaxies, guides stars, and influences the very architecture of space. It is a force both elusive and essential, challenging us to expand the boundaries of perception, imagination, and understanding. Each detection method, each experiment, is a step closer to unveiling the hidden backbone of the universe. A slow but inexorable journey into the heart of cosmic mystery. As you continue to drift through the quiet expanse of the universe, allow yourself to contemplate the profound influence of dark matter on the cosmos. Though invisible, it is everywhere, quietly shaping the structure, evolution, and destiny of galaxies, clusters, and even the universe itself. Its presence is subtle, yet it governs the behavior of everything we can see, reminding us that the fabric of reality is far more complex than our eyes perceive. At the scale of galaxies, dark matter acts as an invisible halo surrounding the luminous disk of stars. Without it, galaxies would unravel, unable to hold themselves together against the centrifugal force of their own rotation. Dark matter provides the gravitational glue that stabilizes spiral galaxies, elliptical galaxies, and even the most irregular, chaotic systems. It ensures that stars orbit in smooth patterns, that galaxies retain their shape, and that clusters of galaxies remain bound over billions of years. Consider galaxy clusters, immense assemblies of hundreds or even thousands of galaxies. Here, dark matter is the dominant force, outweighing visible matter by a factor of 5 to 1. Its gravitational influence dictates the motion of entire galaxies, holding clusters together in ways that ordinary matter alone could never achieve. Without dark matter, clusters would fly apart, and the large-scale architecture of the universe would collapse into chaos. Dark matter also plays a critical role in cosmic structure formation. In the early universe, tiny fluctuations in the density of matter seeded the formation of galaxies and galaxy clusters. Ordinary matter, influenced by dark matter, fell into these dense regions, forming stars, nebulae, and galaxies. Without dark matter, the universe we know, the vast tapestry of stars, planets, and galaxies, may never have existed. It is, in a very real sense, the invisible architect of everything we see in the night sky, beyond individual galaxies and clusters. Dark matter forms a vast cosmic web, invisible strands stretching across millions of light-years, connecting clusters and superclusters. This web guides the motion of galaxies and shapes the large-scale structure of the universe. Imagine drifting through space along these invisible filaments, the galaxies themselves acting as tiny lights along a hidden scaffold that gives the cosmos its form and coherence. The universe is not random or chaotic. It is a carefully orchestrated structure. Held together by unseen forces, the cosmic role of dark matter extends even to the expansion of the universe. While dark energy drives galaxies apart, dark matter pulls them together, creating a dynamic tension between attraction and repulsion, between structure and expansion. This delicate balance determines the evolution of the cosmos, influencing the rate of galaxy formation, the behavior of clusters, and the ultimate fate of the universe itself. Dark matter and dark energy are the yin and yang of cosmic evolution. Forces we cannot see but whose effects define the universe. Even more fascinating is the possibility that dark matter may interact with ordinary matter in ways we do not yet understand. Its gravitational pull is evident, but could it also influence the formation of stars, the behavior of black holes, or the emergence of life in subtle, unseen ways? These questions remain open, inviting scientists and dreamers alike to imagine the hidden connections between the visible and invisible realms. As you drift silently through this cosmic web, you begin to sense the vastness and elegance of dark matter's role. It is not merely a curiosity or an enigma, it is the foundation upon which the universe is built. Galaxies cling to it, clusters dance to its rhythm, and the large-scale structure of the cosmos reflects its unseen influence. Every star, planet, and galaxy owes its existence, in part, to this invisible force. In a very real sense, dark matter is a reminder of the limitations of perception. The universe is far more intricate than our senses suggest. Most of reality lies hidden, accessible only through careful observation, imagination, and the subtle clues it leaves behind. Floating through this quiet expanse, you can feel the presence of this invisible substance, guiding the formation and motion of the cosmos, shaping the universe in silence. Tonight, you are witnessing a universe held together by forces unseen, guided by structures invisible, and shaped by mysteries that remain unsolved. Dark matter is both silent and powerful, subtle and essential. It reminds us that the universe is a vast, interconnected system, far larger and stranger than our senses alone can perceive. Its role is cosmic, its influence universal, and its mystery a source of endless fascination as you drift through the weightless quiet of space. Take a moment to acknowledge the profound elegance of this invisible universe. Dark matter is everywhere, yet hidden. It holds galaxies together, shapes the cosmic web, and orchestrates the grand structure of the cosmos. It is an unseen companion, a silent guardian of the universe, and a reminder that much of reality lies beyond sight, awaiting discovery by patient minds and curious hearts. Dark matter is the invisible heartbeat of the universe, a hidden force that binds, structures, and sustains everything we can see. And as you float through this cosmic sea, you realize that understanding it is not merely a scientific endeavor, it is a journey into the very soul of the universe, a voyage into the hidden heart of reality itself. As you float quietly through the endless cosmos, you may feel a subtle tension in the vast expanse around you. Something unseen is at work, pushing galaxies apart, stretching space itself. This is dark energy, the mysterious force that dominates the universe, yet remains invisible and profoundly enigmatic. Tonight, we begin a journey to understand this strange energy, its discovery, and its influence on the cosmos. Unlike dark matter, which binds galaxies together, dark energy repels, driving the expansion of the universe at an accelerating pace. Imagine the universe as a vast balloon, slowly inflating over billions of years. Galaxies are like dots on its surface, moving farther apart as the balloon grows. But in the late 1990s, astronomers made a startling discovery. The universe is not just expanding, it is accelerating, moving faster with every passing moment. This revelation came from careful observations of Type Ia supernova, exploding stars that serve as cosmic mileposts. By measuring their brightness and redshift, scientists could determine how far away they were and how fast the universe was expanding. The results were astonishing. Galaxies were receding, not at a steady pace, as expected, but at an accelerating rate, implying the presence of a mysterious, repulsive force, dark energy. Dark energy is now believed to constitute roughly 68% of the universe, far outweighing ordinary matter and dark matter combined. It is the dominant force shaping cosmic evolution. Yet we have no direct way of seeing it, measuring it, or fully understanding it. Its nature is one of the greatest mysteries of modern science, challenging our most fundamental assumptions about reality. To imagine dark energy, picture a vast, invisible field that permeates all of space. Unlike a star or planet, it does not clump or cluster. It is uniform, pushing outward everywhere, silently accelerating the expansion of the universe. Its effects are subtle on small scales, but over billions of light-years, its influence becomes dominant, shaping the ultimate fate of galaxies, clusters, and the cosmos itself. Scientists have proposed various theories to explain dark energy. One possibility is the cosmological constant. First introduced by Einstein in 1917, originally conceived as a mathematical device to allow for a static universe. The cosmological constant represents a constant energy density inherent to empty space. In this view, the vacuum of space itself has energy, producing a repulsive gravitational effect that drives cosmic acceleration. Another possibility involves quintessence, a hypothetical dynamic field that changes over time and space. Unlike the cosmological constant, which is unchanging, quintessence would evolve, its strength and effects varying across the universe. This theory opens the door to complex models in which dark energy interacts subtly with matter and dark matter, creating patterns we may one day observe. The discovery of dark energy has profound implications for the future of the universe. If dark energy remains constant, galaxies will continue to drift apart, eventually leaving isolated islands of stars in an ever-expanding void. Stars will burn out, galaxies will fade, and the cosmos will grow colder, darker, and quieter, a scenario known as the Big Freeze. If dark energy increases over time, a more dramatic fate could await: the Big Rip, in which the repulsive force grows so strong that it tears apart galaxies, stars, planets, and even atomic matter itself. Though speculative, this scenario highlights the immense power of dark energy and the profound uncertainty surrounding its ultimate effects. Even in the present, dark energy subtly shapes the universe. Its push against gravity slows the formation of large cosmic structures, influences the distribution of galaxy clusters, and plays a crucial role in the evolution of space over billions of years. It is a silent, invisible sculptor, acting on scales far beyond our everyday experience. As you drift through the cosmic darkness, imagine dark energy as an invisible tide pushing outward on all that exists. You cannot see it, touch it, or hear it, yet it governs the motion of galaxies, shapes the evolution of the universe, and dominates the cosmic landscape. It is a reminder that the universe is governed not only by the visible and tangible, but also by forces far beyond perception. In this moment, let yourself feel the vastness of space, the subtle pressure of dark energy, and the paradoxical nature of a universe simultaneously expanding, structured, and profoundly mysterious. Dark energy is a cosmic whisper, a gentle but relentless push that carries the universe toward an uncertain, unimaginable future. Tonight, in the silence and calm of space, you have glimpsed the first layer of this invisible force. You have begun to understand that the cosmos is not only composed of stars, planets, and galaxies, but also dominated by an unseen energy, stretching space itself, shaping the destiny of everything in its reach. Dark energy is everywhere, quiet yet powerful, enigmatic yet essential, and this is only the beginning of our exploration. As you drift silently through the infinite expanse of the cosmos, let us turn to the story of discovery, the moment when humanity first glimpsed the mysterious force we now call dark energy. Though invisible, its presence revealed itself through subtle, almost imperceptible signs, clues hidden in the light of distant stars and the motion of galaxies. The journey began in the 1990s, with two independent teams of astronomers studying Type Ia supernova, brilliant explosions marking the deaths of certain stars. These supernovas serve as standard candles in astronomy. Objects with a known intrinsic brightness, allowing scientists to measure cosmic distances with remarkable precision. By comparing their observed brightness with expectations, astronomers could determine how fast the universe was expanding at different points in time. What they found was unexpected, astonishing, and revolutionary. The galaxies hosting these supernovae were moving away faster than predicted. Instead of a slow, decelerating expansion driven by gravity, the universe seemed to be accelerating. To teams the Supernova Cosmology Project and the High-Z Supernova Search Team announced independently that the universe was not slowing down, but speeding up. This acceleration could only be explained by a previously unknown, repulsive force permeating space, dark energy. The evidence was initially met with skepticism. After all, acceleration contradicted centuries of cosmological thought, including Einstein's own initial belief in a static universe. Yet further observations confirmed the findings. The cosmic microwave background CMB, the afterglow of the Big Bang, revealed patterns consistent with a universe dominated not by ordinary matter, but by a mysterious energy-driving expansion. Large-scale surveys of galaxy clusters and their distribution reinforced the conclusion. The universe was accelerating. And dark energy was the invisible hand behind it. Gravitational lensing offered another line of evidence. As light from distant galaxies passed through massive clusters, it bent in ways that could only be explained if the universe contained both dark matter and dark energy. The distribution of galaxies and voids, the shape of cosmic filaments, and subtle imprints in the CMB all pointed toward the same conclusion: a force beyond matter, beyond light, pushing the universe outward, even in our own Milky Way. Subtle measurements confirm dark energy's presence. The motion of nearby galaxies, the expansion rate of the local universe, and the distribution of intergalactic gas clouds all provide consistent, indirect evidence of this mysterious energy. Though we cannot see it, detect it directly, or touch it, dark energy manifests in the motion, structure, and evolution of everything around us. The discovery of dark energy has fundamentally changed cosmology. Previously, scientists believed that the universe might eventually slow its expansion, possibly collapsing in a big crunch. Now, the fate of the cosmos is tied to this invisible energy. If dark energy remains constant, galaxies will continue drifting apart, stars will eventually burn out, and the universe will enter a vast, cold, and silent future. If dark energy changes over time, even stranger possibilities arise. Perhaps the universe could tear itself apart in a big rip, or enter entirely new forms we cannot yet imagine. Consider the elegance and paradox of this evidence. It is indirect, subtle, and elusive, yet overwhelmingly compelling. Dark energy cannot be observed directly, yet its fingerprints are everywhere, in the acceleration of galaxies, the stretching of space, and the large-scale structure of the cosmos. Scientists piece together this invisible presence like detectives at a cosmic crime scene, inferring its existence from the traces it leaves behind. The discovery of dark energy is also a testament to human curiosity and patience. It required decades of careful observation, precise measurement, and meticulous analysis. It was the combination of technology, ingenuity, and sheer persistence that revealed this invisible force. Deep underground detectors, powerful telescopes, space-based observatories, and sophisticated computer models all contributed to this breakthrough. Each observation was a small step closer to uncovering one of the universe's greatest mysteries. Floating now in the quiet darkness, you can feel the subtle pressure of dark energy, pushing outward, stretching the very fabric of space. Though unseen, it is as real as the stars, as powerful as gravity, and as mysterious as the cosmic web itself. Its discovery reminds us that the universe is far more complex than what we can perceive with our senses. Most of reality is hidden, subtle, and indirect, waiting for patient minds to uncover its secrets. Tonight, you witness the evidence of this invisible energy, not as a physical object, but as a force shaping the cosmos on the grandest scales. Dark energy is everywhere, guiding the motion of galaxies, influencing the structure of the universe, and determining the ultimate fate of all that exists. Its discovery has expanded our understanding of reality, revealing a universe far stranger, more dynamic, and more mysterious than ever imagined. As you float through the serene, silent expanse of space, let us explore the attempts of humanity to understand one of the universe's most enigmatic forces: dark energy. Though we can see its effects across billions of light years, its true nature remains hidden. Scientists have proposed multiple theories and models, each attempting to explain how this invisible energy drives the accelerated expansion of the cosmos. The simplest and most famous explanation is the cosmological constant. First introduced by Albert Einstein over a century ago. Originally conceived to allow for a static universe, it represents a constant energy density inherent to empty space itself. In this view, even nothingness has energy. This energy exerts a repulsive force, causing the expansion of the universe to accelerate. The cosmological constant is elegant in its simplicity, providing a fixed, uniform push across all of space. Yet it leaves unanswered questions. Why does this constant have the precise value we observe? Why does it dominate the universe only in recent cosmic history? Beyond the cosmological constant, scientists have proposed quintessence. It's a dynamic form of dark energy that evolves over time and space. Unlike a fixed cosmological constant, quintessence can fluctuate, interact with other forces, and potentially vary across the universe. In some models, quintessence could have influenced galaxy formation differently in different regions of space. This theory is more flexible than a constant energy density, allowing for subtle variations and complex behaviors. Yet it is also harder to test and confirm with current technology. Another intriguing possibility comes from modifications of gravity. Some physicists propose that what we interpret as dark energy may actually reflect a change in the way gravity works on cosmic scales. In these models, the laws of gravity themselves are different at enormous distances, producing accelerated expansion without invoking a separate, mysterious energy. While elegant in principle, these models face challenges in matching observations across both local and large-scale structures of the universe. More speculative theories suggest that dark energy might arise from extra dimensions or unseen fields that permeate the universe. String theory, for example, predicts additional dimensions beyond the familiar three of space and one of time. Energy associated with these hidden dimensions could manifest as dark energy in our observable universe. If true, this would connect dark energy to some of the deepest mysteries of physics, uniting cosmology with the fundamental nature of reality, even more philosophically. Some propose the anthropic principle as an explanation. In this view, the value of dark energy is not determined by fundamental laws alone, but is conditioned by the fact that observers like us exist. Universes with vastly different dark energy levels may exist, but only those with values conducive to galaxy formation and life are observed. While controversial, this idea frames dark energy in the context of a multiverse, where countless variations of reality exist, most invisible and inhospitable. With our universe being just one of many possibilities, each of these models attempts to explain the same set of observations. Galaxies accelerating away from each other, the large-scale structure of the universe, and the imprint of energy in the cosmic microwave background. Yet none is fully confirmed, and the true nature of dark energy continues to elude direct detection. It is a mystery not only of physics, but also of philosophy, pushing us to consider what it means to comprehend a universe dominated by something we cannot see. The interplay between dark energy and the expansion of the universe also highlights profound cosmic paradoxes. Gravity pulls inward, gathering matter into galaxies and clusters, while dark energy pushes outward, stretching space and accelerating the universe's growth. This delicate balance defines the evolution of the cosmos, influencing the formation of stars, galaxies, and the very fabric of space-time. It is a dance of attraction and repulsion, structure and expansion, visible and invisible. Even in our daily observations, we are only beginning to glimpse the influence of these theories. Surveys of distant galaxies, measurements of supernova, and observations of the cosmic microwave background provide indirect evidence, clues embedded in the structure of space and time. Each model predicts slightly different outcomes for how the universe evolves, how structures form, and how expansion proceeds, offering a roadmap for future exploration and discovery. As you drift silently through this cosmic landscape, imagine dark energy not as a single phenomenon, but as a field of possibilities. A force that could take many forms, yet whose effects are felt everywhere. It stretches across the universe, invisible yet undeniable, guiding the motion of galaxies and shaping the destiny of space-time itself. This is a universe governed not only by matter and gravity, but also by subtle, pervasive forces beyond our perception. Ultimately, the study of dark energy is a journey into the limits of human knowledge. It challenges our understanding of physics, cosmology, and reality itself. We are forced to confront the possibility that the majority of the universe is governed by something we cannot directly observe, measure, or fully comprehend. Yet it is precisely this mystery that drives curiosity, exploration, and wonder in this quiet, weightless drift. You are witnessing the universe not only as it is, but as it might be, shaped by forces both visible and invisible, known and unknown. Dark energy is the cosmic current beneath the surface of reality, a silent architect of the cosmos, stretching space and time, shaping destiny, and reminding us of the profound mysteries that remain to be explored. As you drift silently through the endless darkness of space, consider the profound question: what does the presence of dark energy mean for the future of the universe? Unlike the stars that burn and fade, or the galaxies that rotate in graceful arcs, dark energy is invisible yet dominant, shaping the destiny of the cosmos in ways both subtle and monumental. The discovery of dark energy has transformed our understanding of cosmic evolution. Prior to its detection, astronomers debated whether the universe would continue expanding forever, eventually slow, or even collapse under its own gravity in a dramatic Big Crunch. Dark energy changed this picture entirely. Its persistent, repulsive force ensures that the expansion of the universe is accelerating, pushing galaxies ever farther apart at increasing speeds. One potential scenario for the universe's future is the Big Freeze. In this vision, galaxies drift further and further apart. Star formation slows and eventually ceases, and the universe cools as matter becomes increasingly sparse. Over trillions of years, stars burn out, galaxies fade, and the cosmos enters a state of quiet darkness. The Big Freeze is a slow, inevitable decline, a cosmic winter governed by the silent push of dark energy. More dramatic is the speculative Big Rip, in which dark energy grows stronger over time. In this scenario, the repulsive force eventually overcomes all gravitational, electromagnetic, and nuclear forces. Galaxies would be torn apart, stars shredded, planets disintegrated, and even atomic structures unraveled. Space itself would stretch beyond comprehension, leaving a universe of dispersed energy with no structures remaining. While extreme, this scenario demonstrates the potential power of dark energy and the fundamental uncertainty surrounding its long-term behavior. Yet dark energy, also provides a window into the origin and evolution of the cosmos. Its discovery reshapes our understanding of time, space, and matter. By studying dark energy, scientists gain insights into how galaxies form, how cosmic structures evolve, and how the universe arrived at its current state. Observations of distant supernova, galaxy clusters, and the cosmic microwave background serve as markers in this ongoing investigation, revealing the fingerprints of dark energy on scales far beyond ordinary human perception. Even closer to home, dark energy influences the motion of galaxies within clusters and superclusters. Though its effect is subtle at local scales, its cumulative influence across billions of light-years is profound. The large-scale structure of the universe's cosmic filaments, voids, kuas, and walls is partially shaped by the interplay of gravity and dark energy. It is the tension between these forces that creates the intricate cosmic web, the invisible scaffolding upon which all visible matter hangs. Dark energy, also, challenges our fundamental understanding of physics. Its existence forces us to confront the limits of current theories, including Einstein's general relativity. It raises questions about the nature of space itself, the properties of the vacuum, and the potential for unknown fields or dimensions influencing the cosmos. Each observation and measurement is not only a scientific endeavor, but also a philosophical journey, asking us to consider our place in a universe governed by forces we cannot directly see. The future of the universe is therefore intimately linked with dark energy. Whether the cosmos drifts into a cold, lonely big freeze, faces the destructive potential of a big rip, or experiences some other unknown fate, its destiny is largely dictated by this invisible force. For astronomers and cosmologists, understanding dark energy is not merely about curiosity, is about predicting the ultimate evolution of everything that exists as you drift silently through the cosmic sea. Imagine the galaxies as islands in an ever-expanding ocean, carried apart by a force we cannot see. Dark energy is the tide beneath them, relentless, uniform, and invisible. It reminds us that the universe is governed not only by what we observe, but also by vast, hidden influences shaping every corner of existence, even as you float in stillness. Consider the paradox of dark energy. It is at once subtle and dominant, invisible yet all-powerful. Its effects are gradual, imperceptible in the moment, yet monumental over billions of years. Dark energy stretches space, separates galaxies, and determines the ultimate fate of the cosmos, all while remaining hidden from our direct senses. Finally, dark energy invites reflection on our own place in the universe. In a cosmos dominated by invisible forces, our existence is both fragile and extraordinary. Life emerges, stars burn, galaxies form, yet all within a universe shaped by an unseen, pervasive energy. Dark energy is a reminder that reality extends far beyond perception, that the universe is far more complex and mysterious than we can fully comprehend, and that each observation is a glimpse into a far greater truth. As you drift quietly, enveloped by the vastness of space, feel the silent power of dark energy around you. It is the force shaping cosmic destiny guiding the expansion of the universe and defining the ultimate fate of galaxies, stars, and even time itself. And in this silent cosmic drift, you're witness to one of the universe's most profound mysteries, a force that is everywhere and nowhere, invisible yet dominant, shaping reality on a scale almost impossible to imagine. As you float silently through the infinite dark of space, it is impossible not to feel a subtle, creeping unease. The universe, as vast and magnificent as it is, can also feel profoundly indifferent, even hostile. Beyond the familiar stars and galaxies lies a realm of emptiness. Vast voids where matter is scarce, light is faint, and silence reigns. This is the first unsettling truth. The cosmos is far lonelier than our imagination allows. These cosmic voids are immense regions of near-complete emptiness, stretching tens or even hundreds of millions of light-years across. They are bounded by filaments of galaxies like the dark spaces between the threads of an invisible web. Here, stars are rare, galaxies are isolated, and time seems almost frozen. If one were to drift into these voids, there would be nothing to anchor, sight, or thaw to true. Infinite darkness. Even the familiar galaxies that fill space can feel alien and terrifying. Many are giant and ancient, containing hundreds of billions of stars, each with the potential to harbor planets and perhaps life. Yet the scale of these galaxies, the distance between them, and the sheer emptiness surrounding them dwarf any sense of human significance. Our sun, our solar system, and even our Milky. We are tiny specks in a universe whose scale is almost impossible to grasp. Consider the notion of time on cosmic scales. Stars live for billions of years. Galaxies evolve over tens of billions. And light from distant galaxies travels for eons to reach us. As you drift through this vastness, you realize that everything familiar, everything tangible, is fleeting. The universe moves at a pace so vast that human lifetimes are almost meaningless in comparison. This perspective, while humbling, can also be deeply unsettling. Dark matter and dark energy, forces we discussed earlier, only add to the eeriness. Invisible, omnipresent, and largely unknowable, they shape the universe on scales far beyond perception. You cannot see them, touch them, or directly detect them, yet they dominate the cosmic landscape. Floating through space, one senses not just emptiness, but the presence of unseen forces, powerful and indifferent, silently orchestrating the cosmos beyond emptiness. The universe contains phenomena that defy intuition and sometimes evoke unease. Black holes, for example, are regions of space where gravity is so intense that nothing, not even light, can escape. Their immense mass bends space-time itself, creating areas where reality as we know it ceases to function. To approach one would be to face the ultimate unknown, a singularity where physics breaks down, and the very fabric of existence is stretched beyond comprehension. Even light itself behaves differently in the universe. Gravitational lensing bends light around massive objects, creating ghostly distortions and multiple images of distant galaxies. As you drift, the universe appears not as a stable, predictable space, but as a dynamic, shifting canvas, a place where perception itself can be deceived. What you see is never fully reality. It is filtered through unseen forces, distorted by immense gravity, and stretched across billions of light years. Cosmic radiation adds another layer of unease. High-energy particles, remnants of ancient supernova and violent cosmic events, traverse space invisibly, striking objects at speeds approaching light, while largely harmless in the vast emptiness between stars. They are reminders of the universe's raw power and unpredictability. The cosmos is not safe. It is indifferent, violent, and relentless. In contemplating the vast scale and isolation of the universe, humans can feel a profound insignificance. Life, civilization, and even planets are temporary blips in a cosmos that will continue long after all familiar structures fade. Stars will burn out. Galaxies will drift apart under the influence of dark energy. And cosmic structures we consider permanent are, in the grand scale, ephemeral. This is the first cosmic horror. The universe is vast, lonely, and indifferent, and humanity is just a fleeting observer. Yet within this unsettling emptiness, there is also awe. The loneliness of space, the scale of galaxies, and the forces that govern them evoke a mixture of fear and wonder. The universe is beautiful, intricate, and terrifying all at once. To drift through it quietly, observing its indifferent grandeur, is to confront the ultimate truth. We are observers of a cosmos that is far larger, stranger, and more unknowable than we can fully comprehend. As you continue drifting through the cold, silent expanse of space, the darkness deepens, and with it comes a sense of awe and dread. Among the most terrifying and mysterious objects in the cosmos are black holes. These are not merely dense stars. They are regions of space-time where gravity is so intense that nothing, not even light, can escape. They are the ultimate enigma, silent, invisible. And absolute black holes come in several sizes, from stellar mass black holes, formed from collapsing massive stars, to supermassive black holes, millions or even billions of times the mass of the Sun, lurking at the centers of galaxies. The supermassive black hole at the center of the Milky Way, called Sagittarius A*, exerts a gravitational pull so immense that it orchestrates the orbits of countless stars across tens of thousands of light-years. Yet, despite its power, it is invisible, detectable only through the effects it has on its surroundings. Imagine approaching a black hole. As you draw near the event horizon, the point of no return time itself begins to stretch. From a distance, your movements appear to slow, frozen as you approach the threshold. The universe beyond continues its normal pace, but your perception of time diverges, warped by the immense gravity. This is time dilation, a cosmic phenomenon predicted by Einstein's theory of relativity. And one of the universe's most unsettling truths. The interior of a black hole remains a profound mystery. Theoretical physics suggests that at the singularity, the core of a black hole, densities and gravitational forces become infinite. Space and time collapse into a point of unknowable extremes. Current physical theories break down here. General relativity and quantum mechanics clash. No information escapes, no signal returns, and the singularity remains hidden. A cosmic secret, guarded by its own gravity. Other extreme phenomena in the universe are equally unnerving. Neutron stars, remnants of collapsed massive stars, are so dense that a sugar cube-sized portion would weigh billions of tons on Earth. Some neutron stars are pulsars, emitting precise beams of radiation as they spin hundreds of times per second, creating cosmic lighthouses that sweep across the universe. The forces at play here are so extreme that matter behaves in ways impossible to replicate on Earth. Even more violent are gamma-ray bursts, brief but unimaginably powerful flashes of energy resulting from massive stellar explosions or the merging of neutron stars. In seconds, a gamma-ray burst can release more energy than the Sun will emit in its entire lifetime. If one were to occur nearby, it could sterilize planets and drastically alter life as we know it. These events, though distant, remind us that the universe is not calm or benign, is a realm of extreme power, indifferent to life. Black holes themselves can merge, sending ripples across space-time known as gravitational waves. These waves stretch and squeeze space as they pass, a silent but profound signal of cosmic violence. In 2015, the Laser Interferometer Gravitational Wave Observatory LIGO detected these waves for the first time, confirming predictions from Einstein a century earlier. The collisions of black holes and neutron stars are not just dramatic, they are reminders that the universe is alive with forces far beyond human comprehension. Even more bizarre are hypothetical objects like rogue black holes wandering the interstellar void, quark stars denser than neutron stars or magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's. The universe is filled with extremes, conditions so violent and strange that they challenge our understanding of physics, matter, and even reality itself. As you drift silently past these cosmic horrors, you may feel a deep unease. The universe is not only vast and lonely, as we discussed earlier, but also home to phenomena of unimaginable power and danger. Stars die violently, matter is crushed beyond comprehension, and energy erupts with destructive intensity. Space is a realm of extremes, a theater of forces that can both create and annihilate on scales beyond imagination. Yet in this unsettling landscape, there is a strange beauty. Black holes, pulsars, and gamma-ray bursts are not only terrifying, they are also essential. They forge heavy elements, seed the cosmos with material for new stars and planets, and shape the structure of galaxies. In their extremes, they are the engines of cosmic evolution. Terrifying yet vital. This duality, beauty and horror, intertwined is a defining characteristic of the universe. As you float through it, silent and weightless, you realize that the cosmos is a place of contradictions, magnificent yet terrifying, structured yet chaotic, visible yet profoundly hidden. It is a realm where the very laws of physics are stretched to their limits, revealing the fragility of matter, life, and time itself. As you drift quietly through the infinite void of space, consider the vastness not only of what we know, but of what we cannot know. Beyond the light of stars, beyond the galaxies mapped by our telescopes, lies a universe largely unobservable, a realm of shadows, probabilities, and forces we can only infer. It is here, in the hidden and unknown, that the cosmos reveals some of its most unsettling truths. One such mystery is the possibility of parallel universes. Modern physics, particularly theories like cosmic inflation and string theory, suggests that our universe may be only one of countless others, each with its own laws of physics, constants, and perhaps even dimensions. These universes may never interact with ours, existing silently alongside us, their existence forever beyond observation. The very idea challenges our understanding of reality. What we see is but a fraction of what exists. Then there are regions of the universe beyond our observational horizon. Light from these areas has not had time to reach us since the Big Bang, leaving vast cosmic regions forever inaccessible. These domains may contain structures, phenomena, or even civilizations entirely alien to our comprehension. From our perspective, they are invisible, but they could influence the observable universe in subtle ways we do not yet understand. The cosmos, in this sense, is far larger and stranger than even our most ambitious instruments can reveal. Consider also the dark sector, which includes dark matter and dark energy. While we discussed their observable effects, their true nature remains hidden. What if there exist forms of matter or energy that interact so weakly with normal matter that we can never detect them directly? Entire realms of physics might be concealed within this invisible sector, shaping reality silently and imperceptibly. We are surrounded by forces that govern the universe, yet we cannot touch, see, or fully comprehend them. Even phenomena we think we understand may harbor terrifying unknowns. Black holes, for instance, conceal singularities where physics itself breaks down. Beyond the event horizon, current models collapse. Information may be destroyed or transformed in ways we cannot observe. Similarly, neutron stars and exotic compact objects might host states of matter completely alien to our understanding. The universe is not only stranger than we imagine, it is stranger than we can imagine. Cosmic radiation and high-energy particles also carry hidden mysteries. Some originate from unknown sources or processes so energetic that they challenge our current models of physics. Ultra-high-energy cosmic rays, for example, travel across intergalactic space with energies billions of times higher than the most powerful human-made accelerators. Their origins remain elusive, hinting at extreme events or objects still hidden from our view. Another unsettling truth is the potential for cosmic catastrophes that remain unseen until they occur. Rogue black holes or neutron stars drifting through interstellar space, invisible until they pass near a star or planetary system, could trigger gravitational disturbances or radiation bursts without warning. Gamma-ray bursts, supernova, and other violent events could occur anywhere, at any time, far beyond our detection until their effects reach us, even more subtly. The nature of consciousness and life may be linked to aspects of the universe we cannot yet observe. If life exists elsewhere, it may be adapted to environments utterly alien to our experience, floating in the vacuum, thriving in extreme radiation, or existing in forms undetectable by conventional observation. The cosmos may teem with complexity, yet remain entirely invisible to us, a silent, hidden wilderness of possibility, floating in this unknowable expanse. You begin to feel the universe as it truly is, vast, indifferent, and unknowable. The observable cosmos is only a small fraction of reality, the tip of a cosmic iceberg. The rest, the majority of existence, remains shrouded in darkness, hidden by distance, invisibility, or fundamental limits of perception. This is perhaps the most profound cosmic horror, the recognition that reality extends far beyond what we can ever perceive, and that the universe's most powerful and consequential phenomena may remain forever unobservable. Yet within this darkness, there is also wonder. The unknown compels exploration, imagination, and humility. It reminds us that human perception is limited, that our knowledge is finite, and that the universe is far richer, stranger, and more mysterious than we can ever fully grasp. In the silent emptiness of space, these hidden truths stretch infinitely, challenging both our intellect and our imagination. As you drift further, enveloped by the cosmic void, consider this: the universe is vast, violent, and mysterious. It is a place of extremes and impossibilities, of invisible forces and hidden realms. And it is also a place of profound beauty, a reality so immense that our observations barely scratch the surface. To contemplate the unknown is to glimpse the universe as it truly is, a cosmic wilderness of wonder and terror, waiting silently beyond the reach of perception. As you drift quietly through the cosmic expanse, universe's vastness and mysteries evoke not only awe but also a profound reflection on existence itself. The truths we have explored: the loneliness of space, the invisible forces of dark matter and dark energy, and the extreme phenomena of black holes and neutron stars, carry deep philosophical and existential implications. Humanity has always sought meaning in the stars. Our ancestors looked up at the night sky and saw constellations, myths, and gods. Today, we understand much more about the mechanics of celestial bodies, yet the universe remains indifferent to our presence. This indifference forces us to confront the fragility and transience of life. In a cosmos governed by invisible forces and immense scales of time, civilizations, planets, and even galaxies are temporary, fleeting structures. The universe will persist long after our species, and perhaps all life, has vanished. The concept of scale itself becomes humbling. A single star, like our Sun, is enormous by human standards, yet it is merely one of billions in our galaxy, which itself is one among billions of galaxies. The observable universe is almost incomprehensibly vast, and yet it is only a fraction of what may exist beyond our perception. Recognizing this scale challenges the notion of human centrality. We are observers in a vast, indifferent cosmos, and our understanding is necessarily limited by both our perception and the universe's inherent mysteries. The unknowable aspects of the cosmos: dark matter, dark energy, singularities, and unobservable regions, so raise questions about the limits of knowledge. Science provides models, observations, and predictions, yet certain phenomena may remain forever beyond human comprehension. The universe may contain forces, structures, and events that our senses and instruments cannot detect. This suggests a humbling truth: the more we learn, the more we realize the vastness of what we do not know. These truths also touch on existential philosophy. The universe's indifference, its silent and relentless expansion, can evoke a sense of cosmic loneliness. Life is rare, ephemeral, and fragile in the face of overwhelming forces. Yet this very awareness can inspire a deeper appreciation for the fleeting beauty of existence. Stars shine, planets harbor life, and consciousness emerges against staggering odds. In a universe governed by randomness and extremes, the emergence of life itself is remarkable, almost miraculous. The extreme phenomena we observe, like black holes and gamma-ray bursts, highlight the universe's raw, uncaring power. They remind us that existence is contingent, survival is temporary, and the cosmos does not bend to human desire or morality. This realization can be unsettling, but it also deepens the sense of wonder. Understanding that the universe is not designed for us encourages humility, curiosity, and the pursuit of knowledge for its own sake. Cosmic mysteries also provoke reflection on the nature of reality, parallel universes, unseen dimensions, and the possibility of unobservable cosmic phenomena challenge our assumptions about what is real. Our senses perceive only a tiny fraction of existence, and even our most sophisticated instruments detect only certain aspects of reality. What we call the universe may be a limited projection of a far richer, stranger totality. This leads to profound philosophical questions. What is truly real, and how much of the cosmos is forever hidden from human understanding? Even the accelerating expansion driven by dark energy carries existential weight. The ultimate fate of the universe, whether it ends in a big freeze, Big Rip, or some other scenario, forces contemplation of impermanence on cosmic scales. Galaxies will drift apart, stars will die, and matter as we know it will become dispersed. Life, if it exists elsewhere, will face similar challenges. This is a humbling and somewhat disquieting vision. Everything familiar will eventually fade into darkness, governed by forces beyond comprehension. Yet within this cosmic vastness and uncertainty, there is also meaning and inspiration. The very act of observation, the pursuit of knowledge, and the awareness of our place in the cosmos are profound. Human consciousness allows us to reflect on these truths, to marvel at the universe's grandeur, and to seek understanding despite our limitations. In this sense, the awareness of cosmic horror and mystery can elevate our sense of purpose and wonder, floating in the silent void. Surrounded by the infinite, consider the paradox of the cosmos. It is both terrifying and beautiful, indifferent yet profoundly intricate. The universe offers no comfort, yet it provides endless inspiration. Its extremes, mysteries, and unknowns challenge human perception, spark curiosity, and deepen our appreciation for the fleeting, fragile life that emerges in the midst of incomprehensible vastness. Ultimately, the philosophical and existential implications of cosmic horrors are not merely about fear. They are about perspective. They teach humility, awe, and reverence for a universe that is far larger, stranger, and more mysterious than we could ever imagine. And in this quiet, endless drift, as you contemplate the cosmic truths, you are participating in a profound reflection, witnessing a universe that is, in every sense, alive with mystery, power, and unimaginable possibility. As you drift through the silent expanse of space, it becomes clear that the universe is not only vast and mysterious, but also beyond the full grasp of human perception. Our senses evolved to navigate a small, familiar environment, a planet with air, light, and gravity. Yet the cosmos is vast, extreme, and alien to our intuitive understanding. What we see, hear, or feel is only a narrow slice of reality. Consider the limitations of human vision. The night sky appears full of stars, yet telescopes reveal billions more that the naked eye cannot perceive. Beyond visible light, there is ultraviolet, infrared, X-ray, and gamma radiation, each carrying information about phenomena invisible to us. Entire galaxies, black holes, and cosmic explosions unfold in wavelengths we cannot directly experience. Reality, in this sense, is multi-layered, and our perception is but a window, a fragile interface with a universe of immense complexity. Even our instruments have limitations. Despite incredible advances in astronomy, we cannot yet detect most of the universe's matter or energy directly. Dark matter and dark energy dominate cosmic structures, yet remain largely mysterious. We infer their existence through gravitational effects and cosmic expansion, but their true nature eludes direct measurement. The universe is filled with phenomena that may never reveal themselves fully to human inquiry. Time and space themselves challenge perception. On cosmic scales, distances are measured in light years, and events unfold over millions or billions of years. Traveling across the galaxy would take lifetimes, and observing distant galaxies means looking back in time. We are temporal observers, seeing the universe not as it is now, but as it was when the light left distant objects. This creates a reality that is always partially hidden, always delayed, and fundamentally incomplete. Even the fabric of reality may be different from what we imagine. Theories such as quantum mechanics, string theory, and multiverse concepts suggest that space, time, and matter behave in ways completely alien to human intuition. Particles exist in probabilistic states until measured. Dimensions may be hidden beyond perception, and entire universes may exist simultaneously without interaction. The edges of reality are not just unknown, they are potentially incomprehensible. Cosmic phenomena also push the limits of understanding. Black holes, for instance, are regions where space-time curves infinitely. Neutron stars host matter in densities beyond comprehension. Gamma-ray bursts and cosmic rays operate on energies far exceeding anything we can produce. Observing these extremes forces us to acknowledge the fragility of human intuition and the inadequacy of everyday experience as a guide to understanding the universe. Even the concept of reality itself becomes uncertain. If the universe is far larger, stranger, and more complex than perception allows, then what we call real is only a limited projection of a far richer, multidimensional cosmos. Our consciousness interprets a tiny subset of stimuli, filtering vast swaths of information into familiar forms. The universe is not fully accessible, not fully knowable, and perhaps fundamentally different from what our minds can grasp. This recognition can be disorienting. To confront the universe's scale, its hidden forces, and its extreme phenomena is to confront the limits of human knowledge and perception. Yet it also inspires curiosity and wonder. Every discovery, every distant galaxy observed, every gravitational wave detected is a small triumph against the vast unknown. Humanity is not omniscient, yet it strives, ever reaching toward the edges of reality, seeking to understand a cosmos that continually exceeds expectation. In this quiet cosmic drift, surrounded by stars, voids, and unseen forces, you may sense both vulnerability and exhilaration. Vulnerable because the universe operates on scales, forces, and energies far beyond human control. Exhilarated because consciousness itself is capable of observing, contemplating, and attempting to understand these very extremes. The edges of reality are a frontier, a place of both awe and trepidation, where human curiosity meets the vast, indifferent cosmos. Finally, this first part of our journey reveals a profound truth. The universe is larger, stranger, and more unknowable than we can fully comprehend. Yet our capacity to explore, observe, and reflect allows us to glimpse even a fraction of its majesty. The edges of reality are not only a frontier of knowledge, they are a reminder of the wonder, mystery, and profound beauty inherent in the cosmos itself. As we venture further into the edges of reality, we enter a domain where intuition falters and the universe behaves in ways that seem almost surreal. This is the realm of quantum phenomena, where matter, energy, and even space-time defy our conventional understanding. The universe at its smallest scales reveals a strangeness that is both profound and unsettling, challenging our notions of causality, determinism, and even existence itself. At the heart of quantum mechanics lies uncertainty. Particles exist not in fixed locations, but as probability clouds. Their positions and velocities inherently uncertain until measured. Electrons, photons, and other subatomic particles do not follow predictable paths, but probabilistic ones. This uncertainty permeates reality at its most fundamental level, suggesting that the universe is not a deterministic clockwork, but a realm of possibilities, where outcomes are never fully fixed until observed. Even stranger are quantum superpositions. A particle can exist simultaneously in multiple states, occupying different positions or energies at the same time. Only upon observation does it collapse into a definite state. This phenomenon, famously illustrated by thought experiments like Schrödinger's cat, implies that the very act of observation shapes reality. At cosmic scales, one can only imagine the implications. Could the universe itself exist in multiple states, or could reality branch in ways that defy comprehension? This leads to the tantalizing and unnerving idea of parallel universes. The many-worlds interpretation of quantum mechanics suggests that every possible outcome of every event spawns a new universe. In this view, every choice, every random quantum fluctuation, creates a branching reality, a cosmos of infinite possibilities, most of which are entirely inaccessible to us. The universe we observe is just one branch among countless others, hidden from perception but fully real, beyond quantum uncertainty. The fabric of space-time itself exhibits astonishing complexity. General relativity describes gravity as the curvature of space-time caused by mass and energy. Massive objects warp the space around them, creating phenomena like gravitational lensing, time dilation, and the event horizons of black holes. Yet, at the intersection of quantum mechanics and general relativity, our understanding breaks down. Singularities, the interiors of black holes, and the earliest moments of the Big Bang exist where the known laws of physics fail, leaving profound mysteries at the edges of comprehension. Physicists speculate that space-time may be quantized, composed of discrete units or atoms of space and time at the Planck scale, far smaller than anything we can directly observe. If true, this would mean the continuum of reality we experience is an approximation, a smooth illusion masking a granular, jittering foundation. The universe at this level is not only strange, it's alien to every intuitive notion of distance, time, or continuity. Even more unsettling are theoretical entities like wormholes, hypothetical tunnels connecting distant regions of space-time. These structures, if they exist, could provide shortcuts across the cosmos or even gateways to other universes. Yet their existence remains purely speculative, and the extreme conditions required to stabilize them may make them inaccessible to any observer. The edges of reality, in this sense, are both tantalizing and profoundly forbidding, possibilities that may never be experienced, only imagined. Entanglement adds another layer of cosmic strangeness. Particles can become linked so that the state of one instantly influences the state of another, regardless of the distance separating them. This spooky action at a distance, as Einstein described it, suggests that the universe is interconnected in ways that defy ordinary space and time. Events occurring across galaxies may be correlated, not by conventional causality, but through deeper, hidden connections that remain invisible to human perception. All these quantum phenomena underscore a profound truth. The edges of reality are not merely distant in space, but distant in understanding. Matter behaves unpredictably, space-time curves and stretches in extreme ways, and the universe may branch infinitely into unobservable possibilities. The cosmos we inhabit is not only vast and indifferent, it is strangely, fundamentally unknowable, even in principle. Yet, for all its uncertainty and alien complexity, the quantum universe also underpins every star, planet, and atom we know. The behavior of particles shapes chemistry, biology, and cosmic evolution. the very processes that allow galaxies to form, stars to burn, and life to emerge are dictated by the same quantum rules that seem so bizarre when considered abstractly. In this paradox lies a strange comfort. The universe may be unknowable at its edges, yet it is coherent and consistent enough to allow existence, observation, and reflection drifting in this realm. Surrounded by the unknowable, one confronts the ultimate edge of reality, a cosmos that is both infinitely rich and profoundly mysterious, where the fabric of existence is woven from strangeness and possibility, uncertainty and law. To explore these edges is to confront the limits of human understanding, to feel both awe and disorientation, and to recognize that reality itself may be far more complex than any observer could ever fully perceive. As we venture further into the limits of understanding, the universe opens up to possibilities that are both exhilarating and unsettling. Beyond what can be observed and measured lies the realm of cosmic speculation, a frontier where physics, philosophy, and imagination converge. Here, the known laws of nature hint at hidden truths, and reality may extend far beyond the observable universe. One of the most profound and controversial ideas is the multiversity notion that our universe is not unique, but one among countless others. Different theories suggest varying multiverse structures. Some propose parallel universes with slightly different physical constants, while others imagine completely distinct realities governed by alternative laws of physics. In some models, universes branch endlessly from every quantum event, creating an infinite tree of possibilities. Each universe may contain its own stars, galaxies, and perhaps even forms of life utterly alien to our comprehension. This concept raises both scientific and philosophical questions. If countless universes exist beyond our reach, what does it mean for the nature of reality? Are the physical laws we observe merely local conditions limited to our own cosmic neighborhood? And if other universes host life or intelligence, how might these entities experience a reality so profoundly different from our own? The multiverse challenges the very idea of uniqueness and forces us to confront the possibility that our universe is only a tiny fragment of a vast, unknowable whole. Another speculative frontier involves cosmic simulations. Some thinkers propose that our universe might itself be a simulation, a digital construct created by a more advanced civilization. While unprovable at present, the simulation hypothesis raises deep questions about perception, consciousness, and reality. If our experiences are part of a simulated system, the edges of reality extend not just outward, but downward, into the mechanisms underlying existence itself. In this scenario, the universe's ultimate mysteries are not only physical, but computational, concealed by the architecture of the simulation itself. Even without simulations, the universe presents futures so extreme they verge on the fantastical. The expansion driven by dark energy may lead to scenarios like the Big Freeze, where stars burn out and galaxies drift apart until the cosmos is a cold, dark void. Alternatively, the Big Rip could tear apart galaxies, stars, and eventually atoms themselves. Some cosmologists speculate about cyclic universes, where big bangs and big crunches repeat endlessly, or universes that bounce through different phases of existence. Each scenario is a reminder that the cosmos operates on scales, forces, and timelines far beyond human experience, and that its ultimate fate remains deeply uncertain. Speculative physics also entertains the possibility of hidden dimensions. String theory, for example, suggests that our familiar three-dimensional space may be accompanied by additional compact dimensions beyond perception. These hidden dimensions could harbor phenomena entirely invisible to us, influencing particle physics, gravity, and the structure of reality in subtle but profound ways. If these dimensions exist, they reveal that the universe is not fully three-dimensional at its deepest levels, and that reality is far richer than any observable slice. Even more unsettling are concepts such as Boltzmann brains self-aware, entities that could spontaneously arise from random fluctuations in an otherwise chaotic universe. In an infinite cosmos, it is theoretically possible for consciousness to emerge without a biological origin, fleeting and transient. Such ideas challenge our understanding of identity, existence, and observation, hinting that consciousness itself may have forms and origins beyond life as we know it. The multiverse and cosmic speculation remind us that the universe we see is only a small and localized expression of a far vaster reality. Our telescopes reveal galaxies, stars, and cosmic events, but countless possibilities remain forever hidden, either inaccessible by light or confined to dimensions we cannot perceive. The edges of reality in this context are not just distant, they are fundamentally unknowable, stretching into realms where human intuition, experience, and even imagination strain to comprehend. Yet in this unknown, there is a profound allure. Speculation pushes the boundaries of science and thought, inviting questions that may never have definitive answers. Are there universes with laws that prevent stars from forming? Could life exist in forms completely alien to our biochemistry? Are we observers in a single, unique cosmos, or participants in a vast, infinite multiverse? These questions are both humbling and inspiring, revealing the limits of knowledge and the boundless potential for wonder. Ultimately, contemplating the multiverse and cosmic extremes deepens our appreciation for the universe we inhabit. It reminds us that reality is likely far stranger than any human mind can fully imagine, and that our understanding, while remarkable, is necessarily limited. At the edges of reality, the universe stretches into mystery, revealing possibilities as awe-inspiring as they are incomprehensible dawned in the quiet of space, drifting among unseen forces and unobservable realms. You are confronted with a profound paradox. The universe is both knowable and unknowable, finite and infinite, structured and chaotic. Speculation may never yield certainty, but it illuminates the vast landscape of cosmic possibility, urging exploration, reflection, and humility in the face of the infinite unknown. As we reach the final edge of this cosmic exploration, we must consider not only the mysteries of the universe itself, but also their impact on human consciousness and our understanding of existence. The edges of reality, quantum strangeness, unobservable regions, dark forces. Multiverse possibilities are not just scientific curiosities. They challenge our notions of identity, meaning, and the very nature of perception. Human consciousness evolved to navigate a small, predictable environment. Yet the universe we inhabit is vast, extreme, and largely unknowable. Recognizing the scale, complexity, and indifference of the cosmos forces us to confront existential questions. Are we unique? Are our experiences significant in the grand tapestry of reality? The edges of reality reveal that life, as fragile and fleeting as it may be, exists in a universe that is largely indifferent to observation, desire, or morality. The concept of a multiverse expands this existential reflection. If countless universes exist beyond perception, each with its own laws and possibilities, then our reality may be just one of infinite expressions. Our choices, achievements, and even consciousness may be local phenomena in a vastly larger context. Yet, paradoxically, this perspective can also be liberating. If the cosmos is infinitely diverse, the uniqueness of our perspective, our ability to observe and reflect, becomes a remarkable occurrence. Consciousness itself emerges as a cosmic lens, a way for the universe to contemplate its own structure and possibilities. Quantum mechanics further deepens this relationship. The idea that observation collapses probabilities into reality implies that consciousness is not passive but participatory. Human awareness interacts with the fabric of reality at fundamental levels. shaping the manifestation of events within certain bounds. This does not imply mystical omnipotence, but it does suggest a profound interconnectedness between mind and cosmos, bridge between perception and the universe itself. The universe's extremes, black holes, gamma-ray bursts, dark energy highlight the limits of human experience. We live on a small planet, shielded from these forces, yet our understanding is informed by them. The cosmos teaches humility. Existence is contingent, survival is temporary, and knowledge is necessarily incomplete. Confronting the edges of reality forces recognition of both human fragility and resilience. We are small, yet capable of perceiving and contemplating the very forces that dwarf us at the same time. These cosmic truths inspire creativity, wonder, and meaning. The same quantum phenomena, multiverse possibilities, and cosmic mysteries that evoke existential humility also provoke imagination and philosophical inquiry. Art, literature, and science fiction have long drawn inspiration from the unknown. Humanity's contemplation of reality's edges fosters cultural and intellectual growth, reinforcing the idea that awareness of vast unknowns can itself be a source of purpose. Our relationship with the universe also influences our future as a species. Space exploration, technological development, and scientific curiosity are driven by the awareness that there is more to discover. The edges of reality, far from being purely abstract, motivate practical inquiry. The pursuit of telescopes, particle accelerators, and interstellar probes. By extending human perception and capability, we not only gain knowledge but also cultivate resilience, adaptability, and imagination, qualities essential for survival in a complex cosmos. Philosophically, the unknown underscores the fragility and preciousness of consciousness. Life and awareness are rare outcomes in a universe dominated by empty space, extreme forces, and probabilistic events. Each sentient mind represents a unique vantage point, a way of perceiving and understanding reality. In contemplating the edges of existence, we recognize that human consciousness is both remarkable and transient. A temporary phenomenon capable of grasping truths far beyond immediate survival needs. Finally, the edges of reality remind us of the importance of humility, curiosity, and wonder. Knowledge is provisional, understanding is limited, and the universe is far stranger than we imagine. Yet our capacity to observe, reflect, and question allows us to participate meaningfully in the cosmic narrative. Consciousness, in this sense, is a bridge between the finite and the infinite, a lens through which the universe glimpses itself, drifting quietly among stars, dark voids, and unseen forces. One can sense a profound truth. The universe may be indifferent, unknowable, and extreme, yet human awareness imbues it with significance. To confront the edges of reality is to confront the limits of knowledge, the fragility of life, and the vast potential of understanding. And in that contemplation, we find awe, humility, and a deeper connection to the cosmos. Ultimately, the edges of reality are not only a scientific frontier, they are a philosophical and existential one. They challenge our assumptions, expand our imagination, and remind us that consciousness, curiosity, and reflection are among the universe's most remarkable phenomena. In this quiet, infinite drift, enveloped by mystery and wonder, humanity finds both its vulnerability and its extraordinary place in the cosmos. As we drift through the vastness of the cosmos, we begin to realize that the universe does more than merely exist. It affects us psychologically. Human beings are wired to respond to vast, unknown spaces with a mixture of fear and awe. Our ancestors evolved to detect threats in the environment. Yet in the presence of the infinite, our minds confront a scale that is entirely alien. The night sky, endless voids, and unseen forces evoke deep-seated feelings that are both unsettling and exhilarating. One of the most profound responses is cosmic awe. When gazing at the night sky, observing distant galaxies, or contemplating black holes and neutron stars, humans experience a sense of grandeur that transcends ordinary experience. Awe expands our perception, making us feel both small and connected to something far larger than ourselves. This feeling is not purely emotional. Studies suggest that awe can alter our sense of time, promote humility, and foster social connectedness, as we realize the broader context in which we exist. Yet alongside awe comes existential fear. The universe is indifferent, extreme, and largely unknowable. The forces that shape reality, gravity, dark energy, quantum phenomena operates without concern for life or survival. Stars die, galaxies drift apart, and black holes consume everything in their path. Human consciousness, aware of its fragility in the face of these immense forces, experiences a mixture of wonder and dread. The same cosmos that inspires awe also triggers a profound recognition of vulnerability. The juxtaposition of awe and fear is particularly evident when considering the scale of the universe. Planets, stars, and galaxies are incomprehensibly large, yet they exist in vast emptiness. Distances are measured in light years, and time unfolds over billions of years. Human life is brief and fragile in comparison, and civilizations appear transient against the backdrop of cosmic time. This perspective can evoke existential anxiety, but it can also inspire a deeper appreciation for the preciousness of life and consciousness. Even phenomena that are invisible or intangible can affect the mind. The presence of dark matter and dark energy, comprising most of the universe yet remaining imperceptible, introduces a psychological tension. Knowing that unseen forces govern the cosmos fosters both curiosity and unease. We are aware that much of reality lies beyond observation, creating a sense of cosmic humility and the unsettling realization that the universe is not fully knowable. Black holes, neutron stars, and gamma ray bursts evoke similar reactions. The idea that matter can be crushed to infinite density, that entire stars can explode in unimaginable energy, or that light itself can be trapped forever, challenges our sense of safety and permanence. These extremes confront human cognition with events and scales that are fundamentally alien, generating a blend of fascination and existential terror. Yet fear and awe are intertwined. The cosmic sublime, a term often used in philosophy and art, describes the experience of being simultaneously overwhelmed and inspired by the immensity of the universe. Fear sharpens awareness, while awe expands perception. Together, they foster reflection on life, consciousness, and the nature of reality. Human minds, confronted by the universe's extremes, are both humbled and elevated. Psychologically engaging with the cosmos can also promote resilience. Awareness of human fragility does not necessarily lead to despair. Instead, it encourages perspective, the challenges of life, the fleeting struggles of existence, and the anxieties of daily living are small in comparison to the vast, indifferent universe. This perspective fosters adaptability, reflection, and a sense of wonder that motivates exploration and creativity. Moreover, the interplay of fear and awe can deepen spiritual and philosophical inquiry. While the universe may not be designed for human existence, it provides endless questions for contemplation. Why do we exist? How did consciousness arise in a universe of immense scale? What is the significance of life in a cosmos largely indifferent to it? These questions are born of the tension between fear and awe, driving humans to seek understanding, meaning, and connection in the midst of uncertainty. Finally, the psychological impact of the universe reminds us that emotional responses are an integral part of cosmic exploration. Observation, measurement, and analysis are essential, but so too are reflection and imagination. The universe evokes not only knowledge but also feeling, fear, awe, humility, wonder, and inspiration. These emotions are part of the human encounter with the cosmos, shaping how we interpret, internalize, and integrate the vastness of reality into our consciousness. As humans gaze into the depths of space, the unknown becomes a mirror reflecting our deepest fears and curiosities. The universe presents phenomena that are not only vast and extreme, but also fundamentally mysterious, evading complete understanding. To confront this unknown is to confront the limitations of perception, cognition, and imagination. Human fear, often arising from uncertainty, plays a profound role in how we engage with the cosmos. Fear, at its core, is a response to uncertainty and the perception of potential danger. In the context of the universe, these dangers are not personal threats, but existential and conceptual. Black holes, gamma-ray bursts, and the relentless expansion of space evoke an intuitive sense of vulnerability. These are not threats we can fight or escape. They exist on scales and in forms that dwarf human comprehension. The mind reacts with a mixture of awe and apprehension, a recognition that the universe is vast, indifferent, and sometimes hostile. Yet fear in the cosmic context is not merely paralyzing. It can also be a source of insight and inspiration. The discomfort of uncertainty pushes human beings to investigate, hypothesize, and imagine. Questions about the origin of the universe, the nature of dark matter and dark energy, or the possibility of other dimensions arise from this tension between fear and curiosity. The very presence of unknown forces challenges us to expand our thinking, adopt new perspectives, and develop concepts that reach beyond everyday experience. Confronting the unknown also illuminates the fragility of human understanding. Even our most sophisticated instruments and theories capture only fragments of reality. The universe contains forces and structures that exceed intuition, quantum uncertainties, singularities, and unobservable matter. Acknowledging these limits evokes a psychological humility, a recognition that human perception is a narrow lens through which only a fraction of reality is visible. Fear of the unknowable reminds us that much of existence lies beyond direct experience, and that some truths may forever remain elusive at the same time. The confrontation with cosmic unknowns fosters creativity and imagination. Myths, science fiction, and theoretical physics all thrive at the interface of fear and curiosity. Imagining alien worlds, strange dimensions, and unimaginable energies allows the mind to explore realities that cannot be directly observed. In this way, fear becomes an engine of intellectual and emotional expansion, motivating exploration, speculation, and discovery. Humanity's response to the unknown also reflects a profound existential awareness. When faced with the vastness and indifference of the cosmos, one becomes acutely aware of mortality, temporality, and the fragile nature of life. Civilization, culture, and consciousness are brief phenomena in cosmic time. Yet within this awareness lies an opportunity for reflection and perspective. The universe's enormity and mystery can instill both humility and resilience, teaching us to appreciate the fleeting beauty of life and the rarity of consciousness. Fear also intersects with cosmic awe in a deeply transformative way. The very phenomena that evoke dread, the collapse of stars, the birth of black holes, the expansion of space, also inspire reverence. Awe emerges from the recognition of vastness, complexity, and the sublime, creating a psychological state where fear and wonder coexist. This duality allows humans to approach the unknown with both caution and admiration, cultivating a mindset that is attentive, reflective, and open to discovery. Furthermore, confronting the unknown shapes our philosophical and spiritual perspectives. Awareness of the cosmos' scale and mystery prompts questions about meaning, purpose, and our place in existence. Are we observers of a single, unique universe or participants in a vast multiverse? Do unseen forces like dark matter or dark energy hint at deeper structures or intelligences, even without definitive answers? The act of questioning transforms fear into a form of engagement, a way to navigate the vast unknown with curiosity, courage, and humility. The interplay of fear and wonder also has practical implications for scientific progress. Recognizing the vastness of what is unknown motivates observation, experimentation, and exploration. The drive to understand black holes, map cosmic microwave background radiation, or detect gravitational waves stems from a desire to confront and comprehend the universe's mysteries. Fear of ignorance, combined with awe at discovery, fuels the human pursuit of knowledge. Finally, confronting the unknown encourages a psychological resilience that extends beyond science. When individuals internalize the enormity and mystery of the universe, daily anxieties and fears can be seen in perspective. Human troubles, while real and significant on personal scales, are small against the backdrop of cosmic forces. This perspective fosters calm, reflection, and a sense of connection to something greater than oneself, turning fear into a tool for understanding and wonder. In this delicate balance between apprehension and admiration, humanity finds its capacity for both reflection and exploration. Confronting the unknown is not merely about knowledge, it's about experience, emotion, and the cultivation of a mind that can dwell simultaneously in fear, awe, and curiosity. The universe, with all its extremes and mysteries, becomes a teacher, guiding human consciousness toward humility, imagination, and a deeper engagement with reality. As we contemplate the vastness of the universe, a subtle transformation occurs within the human mind. The same forces that inspire fear, the incomprehensible scale of space, the indifference of cosmic phenomena, and the existence of unseen forces, also cultivate a profound sense of wonder. Wonder is the emotional response that blends curiosity, admiration, and humility, creating a bridge between human consciousness and the infinite complexity of the cosmos. This sense of wonder shapes how we perceive ourselves and our place in the universe. When looking at distant galaxies, nebulae, or the intricate dance of particles at a quantum scale, we recognize both our insignificance and significance. Insignificant because our lives are but fleeting moments against cosmic time. Significant because we are capable of observing, reflecting, and understanding even a fraction of this vast reality. Human consciousness, in its awareness and perception, becomes a lens through which the universe contemplates itself. The impact of cosmic perspective on the human spirit is profound. Recognizing the grandeur and mystery of existence fosters resilience, humility, and a deep appreciation for life. Daily struggles and minor anxieties, while real, take on a new dimension when placed against the backdrop of billions of years and untold expanses of space. In the quiet contemplation of stars and the unseen forces that govern the cosmos, we find a form of psychological liberation, a reminder that much is beyond our control. And yet, life remains beautiful and meaningful. Wonder also fuels creativity and intellectual exploration. Throughout history, human beings have translated the awe of the cosmos into art, literature, music, and science. The mysteries of space have inspired everything from epic poetry to advanced theoretical physics. Artists imagine alien worlds. Scientists hypothesize about dark matter and quantum fluctuations. Philosophers contemplate the nature of existence and consciousness. The human spirit, in encountering the infinite, seeks to understand, to express, and to connect with the cosmos in myriad ways. In addition, experiencing cosmic awe reshapes our moral and social perspective. When confronted with the scale and indifference of the universe, human conflicts and prejudices seem smaller, more trivial. Shared reflection on the cosmos can foster unity, empathy, and cooperation, as individuals recognize their commonplace within the vastness of reality. Understanding the universe's magnitude encourages ethical and philosophical humility, reminding us that life, in all its forms, is rare and precious, The psychological effects of wonder and perspective also intersect with spiritual exploration. Many have found that contemplating the universe evokes feelings traditionally associated with spiritual experience, transcendence, interconnectedness, and the search for meaning. Whether through scientific awe or metaphysical reflection, the universe invites humans to consider questions that exceed practical survival questions about purpose, consciousness, and the nature of reality itself. Importantly, this engagement with wonder is not passive. It demands attention, reflection, and openness to uncertainty. The universe challenges assumptions, forces reconsideration of known truths, and encourages exploration beyond familiar limits. In this sense, wonder is active engagement with the unknown, a psychological and intellectual practice that enriches the mind and nurtures the spirit. The balance between fear and awe ultimately cultivates a resilient and expansive consciousness. Fear reminds us of vulnerability. Awe reminds us of potential. Together, they create a mental and emotional space where humans can confront the incomprehensible while finding inspiration, beauty, and purpose. The cosmos, in its extremity and mystery, shapes not only our knowledge but also our inner life, guiding the development of both intellect and character. Finally, embracing the vast unknown encourages a lifelong relationship with curiosity and reflection. Even if many cosmic questions remain unanswered about dark matter, dark energy, parallel universes, or the ultimate fate of reality, the act of questioning itself enriches human experience. Wonder motivates exploration, both outward into space and inward into consciousness, creating a continuous dialogue between humanity and the cosmos. In this ongoing engagement, we find the essence of the human spirit, a being capable of fear, yet also capable of awe. Small, yet able to grasp fragments of the infinite. Fragile, yet resilient. The universe is vast, indifferent, and enigmatic. Yet, through the lens of wonder, human consciousness finds meaning, purpose, and profound connection. As this reflection concludes, it becomes clear that the edges of reality and the unknown cosmos are not merely distant or abstract. They are deeply intertwined with the human mind, shaping our fears, aspirations, creativity, and understanding. By embracing both fear and awe, we cultivate a richer, deeper relationship with existence, one that resonates with curiosity, humility, and an enduring sense of wonder. As we reach the end of this extraordinary journey through the dark side of the universe, take a moment to let your mind linger among the stars, the unseen forces, and the vast unknown that surrounds us. Over the past several hours, we have explored mysteries both observable and hidden. From the enigmatic depths of dark matter and the relentless expansion driven by dark energy, to the unsettling and awe-inspiring edges of reality where cosmic horrors and existential extremes dwell. Throughout this voyage, one truth has remained constant. The universe is far stranger and more complex than our minds can fully comprehend. It is indifferent, vast, and often terrifying, yet it is also a source of immense beauty, inspiration, and wonder. The unknown is not merely a void, it is a canvas for curiosity, imagination, and reflection. The dark side of the universe, while mysterious and sometimes unsettling, challenges us to think bigger, question deeper, and explore further. We began by contemplating the unknown universe, discovering how much remains invisible, untouchable, and unimaginable. The stars we see are only a fraction of reality, and much of existence is cloaked in forces and phenomena that evade detection. From there, we dove into dark matter, invisible yet crucial, shaping galaxies and holding cosmic structures together. Then we explored dark energy, a force that drives the universe's accelerated expansion, altering the ultimate fate of everything we know. We also confronted the cosmic horrors and unsettling truths. Black holes, extreme phenomena, and the indifferent vastness that challenges human perception. These forces remind us of our vulnerability but also inspire contemplation and reflection on the significance of life and consciousness. At the edges of reality, we saw how speculation about multiverses, hidden dimensions, and cosmic simulations expands both scientific and philosophical imagination, hinting at truths that may forever elude direct observation. Finally, we delved into human fear and cosmic awe, exploring how the mind reacts to the universe's vastness, mystery, and extremes. Fear, when coupled with wonder, transforms into curiosity, creativity, and inspiration. All bridges the finite human experience with the infinite cosmos, allowing consciousness to grasp, even fleetingly, the profound and often incomprehensible reality surrounding us. By confronting the unknown, humans cultivate humility, resilience, and a deeper connection to both the universe and themselves. This journey is more than a collection of facts or theories. It is an invitation. An invitation to reflect on your place in the cosmos, to let curiosity guide you, and to embrace both fear and awe as essential companions on the path of understanding. The universe may remain largely hidden, but it is in our engagement, observation, and contemplation that it becomes meaningful. Even the mysteries we cannot solve teach us about the scope of existence and the capabilities of human thought. As you listen, drift and absorb these ideas, whether awake, relaxed, or even asleep. Remember that the universe is an endless well of wonder. Its dark corners, unseen forces, and extreme phenomena are not merely scientific curiosities. They are gateways to imagination, reflection, and inspiration. Let the questions linger in your mind. What lies beyond the observable? How does consciousness interact with the cosmos? What unknown forces shape our reality? And what secrets await discovery in the vast expanse of space? We hope this journey has not only informed you, but also sparked curiosity, wonder, and a sense of connection to the infinite. The dark side of the universe is both frightening and beautiful, indifferent and deeply compelling. It reminds us that life, consciousness, and curiosity are rare and precious phenomena in a cosmos that is, otherwise, vast and mysterious. Thank you for joining this 3-hour exploration of the universe's mysteries. Your willingness to venture into the unknown alongside us is what makes this journey meaningful. If this video stirred questions, sparked imagination, or inspired awe, remember that the adventure is ongoing. There are always more discoveries, more phenomena, and more mysteries waiting to be explored. If you are intrigued by these concepts and wish to delve further, consider exploring the origins of the Big Bang, the evolution of galaxies, or the latest research in dark matter and dark energy. The universe is an endless source of wonder, and there is always more to learn. As we close, take a deep breath. Let the vastness of space settle in your mind, and allow yourself to marvel at the infinite possibilities. The cosmos may be dark, mysterious, and sometimes unsettling, but it is also an eternal source of curiosity, inspiration, and awe, from the hidden depths of dark matter to the accelerating reach of dark energy. From the edge of known reality to the mysteries that may forever elude observation. We leave you with this thought: the universe is immense, mysterious, and profoundly beautiful, and your mind, your curiosity, and your consciousness are part of its story. Thank you for watching, listening, and journeying into the dark side of the universe. May your mind continue to wander, question, and marvel long after this journey ends. And if you wish to explore further, consider watching more videos about the Big Bang, cosmic mysteries, and the unseen forces shaping our reality. Until next time, let the universe inspire awe and curiosity in everything you do.